This is a prep course for the Certified Secure Software Lifecycle Professional Certificate. Now, when you're talking about software assurance, the whole concept of lifecycle is kind of the essential way to view this because it's not one single distinct step. It's the entire process that's important. And what we're going to cover here in this course are all those elements. First, we're going to look at the specific security aspects, assurance aspects of specification and design, first two stages in the waterfall. What we're going to focus on are the assurance elements, not so much the actual process of specification and design, which are part of software engineering. Then we're going to move on to implementation, which most of you know is coding. What we're going to look at basically, again, it's the secure coding concepts, the things that have to do with implementing the code in a way that is both correct, but also embodies all the necessary assurance. And then we're going to look at software V&V. Software validation and verification are usually known as testing and assurance or reviews. And when you're talking about that process from the standpoint of secure software assurance, and particularly the life cycle, what you're looking at is how you use tests and reviews in the process of ensuring that the software contains all the elements that are necessary to produce a safe and secure product. And then we're going to look at acceptance. Acceptance is the last stage in the waterfall, and it essentially is a point where you write the check. There obviously are assurance elements associated with acceptance in general. Security is something that's part of that consideration. What we're going to do is focus specifically on the elements of that. And also, we're going to transition into the sustainment process, which is actually pretty much most of the software lifecycle because that's the period of its actual use. And it can be, 10 years. And 10 years is a long time. And so the process basically has to be sustained through that period of time. And the assurance is necessary also during that period. Next, we're going to look at acquisition. Acquisition is a new concept. It basically has come about because software is now a commodity that you buy. It's not something you make like you used to do in the 1980s. And so doing it in a secure fashion up a supply chain is something that's actually a new body of knowledge. And it's something that we're going to look at as part of the security of the software throughout its life cycle. In many respects, I might add, acquisition replaces development as the means of bringing the product into the organization. And then we're going to look at documentation. Documentation is not the user manual. Documentation basically is everything that has to do with the software as it's made visible. And so that includes everything from the source code, which you can see, all the way up to the policy and the strategic planning documents that actually motivated the reason for bringing the software into the organization. And last but not least, we're going to look at the ethical considerations. Software assurance ethics is something that actually is quite important. It has practical applications in the sense that things like patching and vulnerability remediation have to be handled in a way fit within kind of a social framework, not just done simply as a technical exercise. And that's what we're going to discuss in that section. This is basically a roadmap of the course. The first section will be an introduction. It's going to familiarize you with the body of knowledge that we're talking about, and also the general concept of standardized best practice as it applies to the professional life of anybody in the software business. We tend to record our important things, lessons learned, in the form of best practice. And what we're going to do is kind of emphasize or show you how what we're going to talk about here essentially represents best practice for secure software assurance. First step will be secure specification. And that's something that looks at the role of specification in the lifecycle assurance process. Specification obviously is a critical part of producing software, but in any instance, even up to just simply acquiring it, you got to know what you want, what you have. Secure specification nails down the security elements as well as the actual functional elements. And so the process itself has got to be kind of understood in the context of the assurance of the product. Secure design, same thing. There are a number of design issues associated with security. And those are things that we'll basically bring to the front during this part of the discussion. The aim here, again, is to make sure that you understand how design fits in the overall lifecycle process of assuring the code. Secure implementation basically is the code. That's the time when we're going to talk about how we turn what amounts to an abstract concept that's captured in the design into an actual running piece of software. Coding itself is not something that you can cover in a course or even several courses, but there are certain practices associated with doing it securely, and that's what we're going to introduce and talk about here. Testing and assurance. Again, testing and assurance is something that's a integral part of the entire software development process. But there are kind of new things that have to be considerations when you're talking about this from a security standpoint. And what we're going to do is focus on the security aspects of validation and verification, not the kind of the general testing, long list of testing processes you might follow. The next step is sustainment. Sustainment is the long-term maintenance of the code. It used to be called maintenance. It's really operations and maintenance. And what it looks at basically is how you maintain this software in a secure state. Then we'll obviously have to touch on configuration management here, but the whole idea basically behind sustainment is how do you ensure that the code continues to have the properties it needs to have in order to be secure throughout its long life cycle. Secure acceptance we talked about earlier. That's the whole point of of assurance, at least traditionally. And the idea basically is that at the end of the development process, you look at how it's accepted and how it's used. But primarily, it's a way of viewing, of acquiring the code over, by means of the acquisition process. And since code comes up as supply chain normally, as it's developed, particularly a large application, that supply chain and its security is also going to be considered in our discussion here. Next is secure documentation. Secure documentation is really everything that's associated with making the software visible. That includes things like the source code itself, which is how you see what was written, but it also includes policy documents. It includes everything that has to do with security specifications. It includes threat analyses. Anything that essentially impacts the software is documentation. That documentation has to be kept in some organized fashion and associated properly with the software as it's used over time. Last but not least is the issue of ethics. Ethics is a big topic, primarily because this is such unexplored territory that as we begin to learn things about what to do and what not to do, they begin to be placed within an ethical context. How do you produce software and sustain it securely over a long period of time in a socially acceptable manner? And that's what we'll talk about here. Now, all of this is basically not something that you need a lot of prerequisites for, but there's some conditions that you need to bring into this course. First of all, you have to understand that the software process itself is essentially best practice. There's no science here. What it is lessons learned over a long period of time. They've been brought together into a single body of knowledge, and that body of knowledge is standardized, in our case, by the IEEE ACM as a proper way to approach the long-term security of code. You need to understand the software development process. I've referred to the waterfall. Most of you know what that is. If you don't, that doesn't really matter because we're going to basically present it. But the whole idea is that you have to understand that software is developed or acquired through a process. It's not something where it magically appears in the organization or you go out and buy stuff. The idea basically is that you have to go through a series of steps in order to bring the software into the organization in a logical and effective manner. You also have to understand that software has a life cycle. It's born, it lives, it dies. It comes out about as part of a purpose. It ends once its usefulness is terminated. And so, over that period of time, there are phases that it goes through, and each one of those phases is distinct, and it adds to the qualities that the software keeps over that period of time, exhibits over that period of time. Last but not least, software is a profession. There are people that practice this as a series of professional activities. Each one of those activities, part of is how you understand the software process. And each one of those activities is something that a professional understands and exhibits. And so with all that, let's proceed on into our learning process. And hopefully at the end of this, you'll be fully prepared to be a software lifecycle professional.